This is Unit 5, Video 1, the mole. We've got, the mole in chemistry is the way we represent the number of particles in a reaction. Think about it. If we write a reaction, let's just say the combustion of hydrogen. And this combusts to make water. Okay, and obviously we can balance it. Okay, so if we had hydrogens here, we need 2 hydrogen molecules, 4 hydrogen atoms, to react with 1 oxygen molecule, and then we're going to make 2 water molecules. Now, you can obviously see all we've done here is rearrange the atoms, but we have a specific number of particles. Now, the way in chemistry that we determine the amount of substance is we weigh it, or maybe we measure its volume. One of the two. We either weigh it or measure its volume. We need some way to go from the weight of the particles to the number of particles that are there. Because some atoms are really heavy. Think of lead versus hydrogen or lithium that are super light. So their weights are going to give, we need some relative mechanism to get from their weight to the number of particles so we can figure out how much actually reacted, how many particles reacted in the reaction. So to do that, we're going to use the mole. The mole is the way we're going to represent. The mole represents Avogadro's number of particles. Now, the official definition of a mole is the number of particles found in 12 grams of carbon-12. Okay? That number we call Avogadro's number. And Avogadro's number is 6.022 times 10 to the 23. That's the number of particles in a mole. Okay? So this equals 1 mole. Okay? So a mole is a group of particles. Now, what type of particles? All kinds. It could be atoms, it could be molecules, it could be ions. We even use moles when we're talking about electrons in batteries and things. We even use moles when we're talking about photons when they're causing chemical reactions, because a certain number of photons will cause a certain number of molecules to react. So we use the mole, the number, the type of particle, all different kinds, but always generally related to a chemical type species. Okay? So we know the number of particles in a mole. Now we want to think of the number of particles in a mole. That's a big number, a weird number, 6.022 times 10 to the 23. It's actually known to many more significant figures than that. But you'd say, how does that relate to something real world? Well, think of the dozen. Okay? Anytime you use the word dozen, in your mind, you know it represents 12. So I can count by dozens. If I say there's 6 dozen donuts, that doesn't mean there's 6 donuts. It means there's 6 dozen. So you know, if you want to know the number of donuts, I'm going to multiply by 12. I've got 72 donuts. Exact same with the mole. If I say there's 6 moles, I'm going to take that 6 and multiply by 6.022 times 10 to 23 particles. Because every mole has that many particles. Just like every dozen has 12 of whatever you're counting. Just like the dozen doesn't have to link to a certain type of stuff. I can talk about dozen eggs, dozen donuts, talk about dozen bicycles, dozen cars. Same way, the number of particles does not have to link to a certain thing. So we're going to have the number of particles found is 6.022 times 10 to the 23. One other thing that we want to understand about the mole is its relationship to the periodic table. One of the nice things about the periodic table is the average atomic mass is the mass of an element to make 1 mole. So if I look at zinc here, which is 65.39, 65.39 grams of zinc contains exactly 1 mole of zinc atoms. Now you go to another element like silver, 107.87, that means 107.87 grams of silver contains exactly 1 mole, or 6.022 times 10 to the 23 particles, or atoms. So we're going to use that extensively in chemistry, because we said at the beginning, we want to be able to connect grams to the number of particles. This is going to do it. The periodic table is going to tell us how many grams are necessary to produce a certain number of particles.